All right. Good afternoon, everybody. It's our pleasure to be here. It has been an incredible experience. It's my first hackathon as well as for our team. I want to quickly introduce it. First, we have Olga Golovina. She's originally from Russia. We have Markus. He's with the Ruhr University in Bochum. By the way, Olga, she's with the Hochtief, a construction company in Germany. And we have Manuel. He's also a bachelor student at Ruhr University in Bochum. And we are a mixed and interdisciplinary team of civil engineering, construction informatics, and mechanical engineering. So it's the skill set that you need to deliver high-power projects. Our team name, we thought about Bacon, and it's related to beacons. You might be familiar with that. On the bottom, you see an image of interdisciplinary teamwork, how it's done in the United States, where people discuss a model in a team environment. At the construction site, on the left-hand side, you see stickers that discuss lean construction management. And I'm going to that in a bit detail to define our problem. A couple of years back, I was in the United States visiting a project from Floor Construction. They actually had modeling in place as well as is data collection in the field. They used tablets and reported that manually in the field, basically clicking by hand on a tablet and reporting progress on site into the field offices. That was a great learning experience. If we go to another country, in Finland, I took those images on a construction site by Skanska. You actually can go to a construction site and pull up the model on a tablet and visualize what it should look like, and obviously through looking at the real site experience what they have built. And you see already there's a slight difference between the water pipes that they have installed. So far so good, but pretty much everything is done manually and there's really no automation to it. And we thought about it's a really critical thing in terms of collecting data automatically in the field. I think that's one of the biggest problems in construction right now, to get BIM implemented on construction sites. We plan very well, most of you are architects, that's working somewhat well. Obviously there's some processes that have to be improved, but on the construction site really BIM hasn't been implemented yet. I'm showing you here an example from a big construction company in Germany. When they do lean construction management, it's all about discussing, meeting, and all of that stuff is great. However, it takes them a long time to collect the information and then to make informed decisions, and that part we want to change. It's so important. I've seen it with so many different companies. All right. Another problem we have is related to productivity. Now is safety. You know the inverse curve of safety and productivity. The safer we plan a job site, the more productive we are. And that's actually the buy-in into safety. You can convince your CEOs, if we plan our job site safer, we actually can work more productively. That saves us money. We picked a very specific scope here for our hackathon. We didn't have much time, and we really drilled down into the detail, and we actually wanted to measure lighting inside the work environment. And as soon as lighting gets worse, we actually are not allowed, according to rules, laws by the government, to perform the work. And here I pulled a record from OSHA, and those records are pretty much known to very few people, typically experts, site inspectors, or in Germany called Sicherheitskoordinatoren, which are at the job site or sometimes often are not at the job site, which pretty much leaves the workers alone in their judgment, can I work here or should I not? The other part is if you have poor lighting conditions, it affects your quality of work, and you want to make sure that you have high quality work, otherwise you have rework, it adds costs to the construction project. So these rules exist, they are written up in books. You see here on the bottom an engineer and safety engineer that knows all of that. It's in his head, but it's really not well applied to information models. There's one rule that's, for example, which measures lighting conditions. It says 5-foot candles. It's pretty much a lux value of over 50. That is appropriate for doing safe work on a job site and producing high quality work. On the right hand side you see the current procedure. People print drawings and they hand mark where light bulbs, very bright light bulbs, are installed in interior buildings. And you see this takes time. It's often not optimized. There might be dark spots where you would not be able to work. And actually we want to give people tools in their hands where they can check is there enough lighting, and then they can install the proper lighting technology for their work. So what we thought is the concept. It's pretty much using a smart helmet. Where's our helmet? Here we go. Thanks, Olga. So this is a prototype. It has here. It's actually the wrong location. I mean, you cannot mount and destroy a helmet by drilling just a couple of holes. Just as a side note, it impacts the stability of the helmet. But anyway, we did it here just for demonstration purposes. It's a 3D printed enclosure. We established the AEC sensor. That sensor can do a lot of things, measure temperature, measure light, measure all kinds of things, humidity. And we connect this sensor here with a Bluetooth low beacon that we install in rooms. And yeah, that gives us the connection then through an Android smartphone and the beacon to the Azure cloud, and a lot of data is being processed there, as well as we connect it to Dynamo, which connects to Revit, where we have our building information model. All of that stuff was really done this weekend. It was a big goal in my life to get this stuff done, and those 3 kids, they did it. It's really impressive. The other part is we didn't use any nodes like or Excel sheets. We directly go from the cloud to Dynamo, and I think that's another thing, to simplify the process as much as you can. Obviously, we have the safety application. At the same time, we can impact lean construction management, but that's stuff that we will do in the future. Now, we will have a short demo that those folks will be doing. Let's cross fingers that everything works.
Okay, I will show you our live demo, and all you see is done this weekend, and so it's very prototype, and as you can see, it's a model of this room, and we have divided the room in 4 areas. One area is right here, and we have placed 2 beacons. One is simulated by my smartphone over there, and another beacon is over there. And we have this Android app which measures the light of the with the lighting sensor of the mobile phone. We didn't connect the helmet because of time issues. So what the app does is to measure the light and to get the position of ourselves with the beacons. So we get the information of the lighting and the room. We upload the information into the Azure cloud, and in the cloud we process this information, and we can get feedback if it's too dark in this room. And well, I can show you if I put my fingers on this sensor, we can see the worker gets the feedback on the smart device, and maybe another person back at home can see, oh, the room is too dark, and can check it. So we will show you what happens if we move to the room over there, and hopefully it detects the change of the room. So maybe. Yeah, it changed. So so all the data we upload to the Azure cloud is collected, and after the project we can analyze the data. We can look how long a worker has worked in one room, and we can use all this data to for the lean management in construction, and get better get time planning, and yes, that's it.
Okay, as we switch back to the PowerPoint, obviously there's various applications which can be followed through. Here's just the again the backup slide. I think we don't have to show that, but actually if you see, have your cell phone with you, you can actually visualize it. So it's actually a personalized feedback on the right hand side where you can actually get that feedback if you need it. I mean, obviously this is a very particular application, but I've experienced that on job sites where OSHA inspectors had issues with that and they were not able to measure it. They had very complex measurement techniques to measure the lighting conditions. We simplify that process tremendously. It saves them time, speeds up the process. On the left-hand side, we envision even a command center, which will happen anyway for construction, where a site inspector can oversee job sites for multiple construction sites, not just one, etc. I mean, these are all kinds of models, business models I can think of. Here, Markus mentioned it already. In our other research, we actually have billing information models. We draw automatic schedules from that. We will show that information to the construction trades as they have to go out, provide them with detailed instructions, knowing where they have to go according to the lean construction management methods. They will then be able to push buttons, hopefully the green button saying that they have done the work. A construction manager can check quality, report feedback, all of those tools. Some of that, Autodesk has some tools already available for quality measurement, etc. But all of that will be done through interaction with cloud services. Well, I want to point out one thing. I'm really thankful, first of all, for our team to be here. Secondly, we will have an international conference next year in Berlin, and what I'm trying to organize with the help of everyone here is to bring this hackathon to Berlin, which is another cool city. I think there are two big cool cities in Germany at minimum. One is Munich, obviously. The other one is Berlin, and a lot of good stuff will be going on there. And I'm the conference chair together with other faculties, and from the TU Berlin, for example. And we want to organize this event there again. It should be a great success, and we have international students from everywhere participating. It would be wonderful to get your participation and support.
Bacon? Gotta get that bacon! Smoky bacon, crispy bacon, tasty bacon! Where is it? Where's the bacon?
Bacon popular, story at 11.
Yummy, crunchy bacon, bacon, bacon! There in that bag!
Who wants a bacon strip?
Me, I get it myself, but I don't have thumbs! Yum, 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 it's bacon! I love you. I love bacon, I love you. I love bacon, I love you. I love bacon, I love you.
Bacon strip, made with real bacon. There's no time like bacon time.
So bacon, you now understand why we chose the team name Bacon. It refers to beacons, but let me say one word to beacons. There's several technologies. We've experimented with several of those ones in our labs, ultra-wideband, other technologies for real-time location tracking, and they all have limitations, same to iBeacons or beacons. Make sure if you use anything that it works reliably, especially if you work with safety. But I think what we solved here is getting any sensor data in with Dynamo Azure and connect it with cloud and visualize it in real time. I'm really, really proud of what they have done, and thanks for your time.
Can you share this to other people, for example, in open source, because they can study it a little bit more and try themselves?
Absolutely no problem. I think we have to figure out the proper outlet, whether on our website or on our university website. Shouldn't be an issue. Would be more than glad to do that.
Maybe AEC Hackathon has some.
We put it up.
GitHub there, so
Yeah.
if you can publish it there, it would be very nice. And same thing with the other team, this search and rescue, if they can. I think it's always bonus when we are thinking the winners.
They just said that they will do that, so I see them in the back. Yeah. Good. Well, thank you very much.